Okay, class, so we're going to take notes a little bit differently today. I want to know if you like this style better, me projecting my computer onto the screen, or me standing in front of the whiteboard and doing notes. So just let me know. But today we're going to be doing section 4, operations with radical expressions. So like radicals, they have, my pen's not on, here we go. They have the same radicand. They have the same radicand. Remember, radicand is that word for whatever is underneath of the square root. So the radicand is what is inside of the square root. And we can combine like radicals. So if we look here, if I want to simplify the square root of 2 plus the 3 square roots of 2. So if I have 1 square root of 2 and I want to add it to 3 square roots of 2, then you can add the coefficients. You can add these coefficients here, 1 plus 3. So this is going to be 1 plus 3, which you know is 4. So then you will be left with 4 square roots of 2. And so that would be how you can combine radicals with the same like radicands. So think of it as if you have an x plus 3x, just treat the radicals as if they were variables. Okay, look at this next one. We're going to simplify 7 square roots of 3 minus the square root of 12. Now notice here that the radicands are not the same, but I can simplify here 12, the square root of 12. So perhaps I can simplify this so that I have the same radicand square root of 3. So remember how to do this. Break this up. You're looking for a perfect square times something else. Okay, and the square root of 4 is 2, so I can bring that out front. Square root of 4 is 2. And then I have the 2 square roots of 3 left over. Bring down your 7 square roots of 3, and we're subtracting here. So I have 7 minus 2 square roots of 3, which will leave me with 5 square roots of 3. Is my simplified answer. We can also evaluate with the distributive property with radicals. Okay, remember that you multiply the outside number times the first term and the outside number times the second term. So this will be the square root of 3 times the square root of 6 plus the square root of 3 times the square root of 7. So on the left-hand side, I'm going to multiply the square root of 3 times the square root of 6. Okay, we can do this. I'm going to keep the 3, but multiply by the factors of 6. And I'm going to choose 3 and 2 because now if I have 2 3's, 3 times 3 is 9, the square root of 9, I can then just take out one of these 3. So if for every 2 on the inside, you get to take 1 to the outside. So this is 3 square roots of 2 plus, now I have square root of 3 times 7, so 7 square roots of 3. Okay, and I can't do anything else here. This is the most simplified that this will ever be because I cannot simplify the square root of 2 any further, and I cannot simplify the square root of 3 any further. Therefore, the answer is the square root of, 3 square roots of 2 plus 7 square roots of 3. And this one we need to remember our FOIL method, how to multiply binomials, okay? Remember your first numbers. So my first square root of 5 times square root of 5. So that's going to be the square root of 5 squared plus my outer numbers, okay? So plus my outers square root of 5 times square root of 15 plus the square root of 5 times square root of 15 plus my inner values, which would be the negative 2 square roots of 5 times square root of 5, so plus negative 2 square roots of 15 times the square root of 5. And lastly, your last values. So that would be negative 2 square roots of 15 and the square root of 15. So negative 2 square root of 15 times the square root of 15 here. Okay, now let's simplify here. The square root of 5 squared is going to be 25 plus, these are where my outers, inners, and last, the square root of 5 times the square root of 15. Okay, 5 times 3, because we're looking for those perfect squares. 5 times 5 is 25. Take the square root, and you're taking out this 5. So you'll have 5 square roots of 3 as your value here. okay, plus negative 2 times, again, 5 times 3 times 5. I see 2 5s. I can take 1 out. Now, when you take this out, you're going to be multiplying, right? When we did it over here, we did multiply. We multiplied, though. We had a coefficient of 1. So this was 5 times 1, which gave us this 5 here. Now, this time I'm going to multiply 5 times negative 2. So this is minus 10 square roots of 3, and now plus my last, which is negative 2, and notice I have the square root of 15 squared, which I can evaluate. 15 square root of 15 squared is 15, times negative 2 would be minus 30. Okay, now I can simplify my like terms. So I have two numbers here, 25 and negative 30. Okay, so I have square root of, oh, I'm sorry, here, this was the square root of 25, which is going to give us just 5. I'm sorry. Here we go. So correct that. And so 5 minus 30 is going to be negative 25, plus my like terms here, 5 square roots of 3 minus 10 square roots of 3 would be a negative 5 square root of 3. So your final answer, and you could write it even simply, typically you would put the square roots first. Negative 5 square roots of 3 minus 25 would be proper math grammar as your final answer. Okay? Okay, and in the next part of the lesson, we're going to learn about conjugates. And conjugates are the sum and the difference of the same two terms. Okay, and what's neat about conjugates is that the product of your conjugate, so for example, if I have the square root of 5 plus the square root of 2, and its conjugate, which is going to be the square root of 5 minus the square root of 2, then the result should be the difference of two squares. And if you remember from previous chapter, the difference of two squares looks like a squared minus b squared. So let's see if this is true. Okay, using our FOIL method, F-O-I-L, we're going to multiply my first, which is the square root of 5 squared, plus my outers, the square root of 5 times negative square root of 2, plus my inners, the square root of 2 times the square root of 5, plus my last, square root of 2 times the negative square root of 2. Okay, so the square root of 5 squared, opposite, so this is 5 plus 5 times 2 is 10, negative 10, the square root of 10, plus 5 times 2, positive 10, positive square root of 10, plus here I have square root of 2 times negative square root of 2. So these negative here is on the outside, so it stays on the outside. So this is a minus, and square root of 2 times the square root of 2, square root of 2 squared is just going to be 2. So notice if I have a negative square root of 10 and a positive square root of 10, those will cancel. So I'm left with 5 minus 3. With a final answer of 2. So now I just took two very complicated looking radical products here and turned it into a nice clean number of 2. So let's see if now this rule works if we were just to use our law over here. Okay, now notice here I was given, I'll use a different color, the square root of 5 is a and the square root of 2 is b. So let's say a is the square root of 5, b is the square root of 2. Then you can plug in those values, okay, the square root of 5 squared minus the square root of 2 squared, and the square root of 5 is 5 minus the square root of 2 squared is 2, 5 minus 2 is 3. And I just am realizing that I wrote it backwards over here. My apologies, you may have just caught that. And you're saying, Miss Ayers at the camera and I can't hear you. Alright, so the answer should match here. They should both be 3. And so this is going to be really helpful to us when we come down here to rationalizing fractions again. And you can rationalize fractions by multiplying the denominator and the numerator by the conjugate. So let's look at this first example, okay? I have the square root of 5 minus the square root of 2. We know in order for this to be simplified, I cannot have square roots in the denominator. So that means I can multiply here by the conjugate, okay? The square root of 5 plus the square root of 2. And whatever you multiply the denominator by, you must also multiply the numerator by, okay? So we've already done this bottom piece here. This is the same as up here. So we already know that the denominator is going to become 5 minus 2, which will become 3. And now I need to multiply the numerator. So I'll have 6 times the quantity, square root of 5 plus the square root of 2. And I want to wait to distribute because notice what happens here. If I bring this along, then you might see it. Oh, I drew that line a little bit too long. Redo that. The square root of 5 plus the square root of 2. Okay. And notice here that I can simplify my whole number pieces here, 6 over 3. Okay, I can simplify that. 6 divided by 3 is 2. So now I will have 2 square roots of 5, 2 times the quantity square root of 5, plus the square root of 2, which I can then simplify by distributing 2 square roots of 5 plus 2 square roots of 2. And that's as simple as I can be because I cannot combine these. They are not like radicals, as we discussed earlier. Okay. Now, had you distributed from the beginning, at the beginning you'd have 6 square roots of 5, 6 square roots of 2, then you would have just individually divided by 3 to still wind up with the same answer, 2 square roots of 5 and 2 square roots of 2. So it's your preference. I like to keep mine out front. I think it's easier just to do one division instead of 2 separate divisions. Okay. For this last problem, they talk about the golden ratio, and the golden ratio is a kind of like one of, they say, magical numbers in mathematics. So you can watch this little video. They talk about it using it in photography, and they compare it to the rule of threes. And so watch the little video. You don't have to in order to do the problem, but I thought it would give you a better understanding of what the golden ratio is. And so the golden ratio is 1 plus the square root of 5, okay, to 2. And in terms of photography, this is your length compared to your width, okay? So then I'm going to ask you, if a painting is 81 inches long, let's find the width. So remember, I gave you a ratio, and this ratio here is using ratio notation, but we can also write a ratio as a fraction. So let's write 1 plus the square root of 5 over 2, where this is the length in the numerator and the width in the denominator. Now, if the painting is 81 inches long, right, I want to find the width. So this is a proportion problem where 81 should go in the numerator because I already established that my lengths are in the numerator, divided by the width that we don't know. So we'll use a variable here. Now remember, to solve proportions, we need to cross multiply. So you can multiply here. I'm going to bring the w out front. 1 plus the square root of 5 is equal to 2 times 81. Okay. So now to solve for w, you need to divide both sides by 1 plus the square root of 5. Divide by 1 plus the square root of 5 on both sides. So these will eliminate. If you divide by the same thing, divided by itself is going to be 1. So now you're left with, I'm running out of room here, w is equal to, okay, go ask Daddy to open you that one. Go on. 162, okay, divided by 1 plus the square root of 5, okay? Then we need to rationalize this answer, so I'm going to bring it up over here. To rationalize this w, I would then need to multiply the numerator and the denominator by the conjugate of the denominator, which is going to be 1 minus the square root of 5. And using our law that we just learned is we don't need to actually FOIL out the denominator. If I take my a piece, which is 1, and square it, okay, then so now I can multiply here 100 and so now I can multiply the numerator, 162 times 1 minus the square root of 5. I'll just leave it like that. And in the denominator, I have that 1 squared minus 5 square root of 5 squared, which is going to be 162 minus, so we're going to have 162 minus 162 square roots of 5, all divided by Now 1 squared minus 5 squared, 5 squared here will be eliminated, so 1 minus 5 is negative 4, okay? Then you can type all of this bad boy into your calculator, and you would get a width that is approximately equal to 50 inches. Okay, remember when you type this into your calculator, put this top numerator in parentheses, so you could do parentheses 162 minus 162 times the square root of 5, end your parentheses. Then hit the divide button and negative 4 in order to get the correct answer. Okay, as always, if you have any questions, reach out to me. My email, phone call, text, always available. Hope you guys are doing well. Let me know if you need anything. Bye.